Hello everyone. The topic of discussion for today is the various factors in electrical engineering. And these factors which we will discuss today are form factor, and second peak factor, and third is the ripple factor. Okay. So let us go one by one. First one is the form factor. The definition for the form factor is it is the ratio of RMS value of the quantity with the average value of the same quantity. This is the definition for the form factor, or it can also be voltage RMS divided by voltage average. Okay, now the next one, that is our peak factor. And the definition for the peak factor is it is the ratio of the maximum value of the quantity with the RMS value of the quantity. That is, let us say the I max divided by RMS, or the V max divided by V RMS. This is peak factor. And now comes the ripple factor. So before understanding the ripple factor, first of all we will try to understand what is ripple. The ripple is AC fluctuation in the output of rectifier, and one of the major reasons, the major reason for this AC fluctuation is because, as we know, that in the rectifiers the various power electronic devices are used, or the electronic devices are used at the signal level, such as diodes and thyristors. Okay, and because of noise into these devices, there is AC component also in the output of rectified DC quantity, and because of which that ripple is there, and because of that ripple we are studying the ripple factor. So the ripple factor is it is the ratio of the RMS value of AC component in output with the DC component of rectified output. This is our ripple factor definition. Or now, in order to understand this in a better way, we will take an example here. Okay, let us say this is the output of a rectifier. Okay, and this is the this is the expected DC output, and this is the actual DC output. So this figure is self-explanatory in itself, that why there is a mismatch in the output of actual and expected. We are expecting a flat DC line, but there is this AC component also there into it, and because of which this is not exactly the a flat DC line, and there is some AC component along with that, and this mismatch is causing the ripple, and because of which the ripple factor is coming to the picture. So now we will try to calculate the value of ripple factor. So first of all, we will write the what is ripple into this. The ripple value is the I load minus I DC. Here the actual DC output, we are calling this as IL, and this expected value of DC we are calling this as IDC. Okay, which we have taken here. So if we can calculate the RMS value of this ripple, the RMS value, then we will be able to calculate the ripple factor. Okay, so what we will do is we will try to find out the RMS value for the ripple. So now the ripple's RMS value will be equal to, as per the formula, 1 by time period 0 to time period integration IL minus IDC square d omega t. Okay, now we will solve this further. Under root 1 by time period integration 0 to t, open the square, IL square plus IDC square plus, sorry, it will be minus 2 IL IDC into d omega t. And if we open this, this will be divided into 3 integrations: 1 by t, 0 to t, IL square d omega t plus integration 0 to t IDC square d omega t minus 2 integration 0 to t IL IDC d omega t. Okay, now we will solve this further, and as we know that integration under root of 1 by t 0 to t, sorry, we will not take the under root here. As we know, the 1 by t 0 to t IL square d omega t is known as IRMS. Okay, IRMS, that is the RMS value of load current. Okay, and the IDC is a constant value, so the integration of this will be the similar value, or we can say that 1 by t 0 to t IDC d omega t will be equal to IDC square is a constant value, so we can take that out from the integration. IDC square by t into, and it will be t minus 0. If we solve the integration, so t will cancel with t, it will be equal to IDC square. Okay, and now the third integration, 1 by t 0 to t IL into IDC into d omega t will be equal to, as we solved in the previous case, that IDC is a constant quantity, so we will take that out. IDC 1 by t 0 to t IL d omega t, and that value is the average value of load current, or also the IDC. So it will be equal to IDC square. So now we have solved all the three integrations. I will show you again. This is our first integration, this is our second integration, and this is our third integration. Okay, so we have solved all of them one by one, and now we'll put directly their values. Okay, so I can write this whole as under root IRMS square plus IDC square minus 2IDC square, or it can be written as IRMS square minus IDC square. This is the RMS value of ripple. Or we can say that this RMS value of ripple is the RMS value of the AC component available into the output of rectifier. Okay, so simply by using the formula for the ripple factor, we can write this as that IRMS square minus IDC square ratio with IDC. This is the value of, or the formula for, the ripple factor calculation. Okay, now if we solve this further, if we take this IDC also under the under root, we will write this as whole under root IRMS divided by IDC square minus 1. And if you remember, as we wrote the formula for the form factor, this was the formula for the form factor, because the form factor is IRMS divided by I average, and the DC value is also called the average value. This is also called as I average. Okay, So from here we can write the ripple factor is equal to under root of form factor square minus 1. So this is the relation between form factor and ripple factor. So instead of calculating the all the value of RMS for the ripple, we can, if we know the form factor directly, we can directly calculate the ripple factor from there. So these are the three topics which we have covered into this video. If you like this video, please do share it and also comment below. Thank you so much for watching.